Welcome. Let's solve Leetcode 1792 maximum average pass ratio. Okay, let's go over the problem description. So we're given a list of classes it's actually a two-dimensional list where the first index stores the number of students that have passed, and the second value stores the total number of students in that class. So in this example, there would be a total number of two students and one student passed. In this next class, there are 5 students in the class and 3 of the students passed. In the last class, there are 2 students and all 2 of the students have passed, 2 out of 2. What they provide for us also is this extra students, and in this case it's 2. So they want to know if we add the students, these extra 2 students, and these extra students are guaranteed to pass. They want to know where should we place these extra students. And remember, these students they're guaranteed to pass. Where these students are guaranteed to pass. Where would it make most sense, or where could we most improve our average pass ratio when placing these students optimally? So for example, in this case, you can assign the 2 extra students to the first class. So when you assign 1 student, 2 becomes well, you're adding 2 students, so 2 plus 2 is 4, 2 plus 1 is 3. And then when you sum up all of the ratios, the pass ratios, and divide it by the number of classes, you get this average pass ratio. So they want us to return this. And our task is to figure out which class to add the students to and how many of those students to add them. So we have 2 extra students. In this case, they decided to place them here, but we need a way to figure out, well, how would we know that maybe placing the students here would be better? So that's our job. Okay, what we'll be using is a heap, a max heap, to figure out where to place those extra students. Okay, so let's go over it. I think that's enough to get started. So what we'll do is I've written down some classes. So just as a reminder, the first value represents the students that pass, and then the second value is the number of students in class. Okay, and in this case, let's suppose we have 1. All right, extras students that are guaranteed to pass. We'll just say k equals 1. Okay, so let's figure out where to do it. So what we'll do first is we'll calculate if we let's write it down. So we will calculate either the profit or the gain we obtain when we add the extra student that is guaranteed to pass. Okay, so let's look at this first class here. So 1 out of 2. So currently we're 1 out of 2, which is 50%. or let's leave it as decimal 0.5. That's fine. If we add another student, that means, well, now we have 2 students that pass, but now we have a total of 3 students. So let's go back here. Let's do something like this, maybe. Which gives us, what is this? 0.67, 0.667, something like that. And then let's look at the other one. So this is 3 out of 4. So 3 out of 4, which is 75%, 0.75. And if we add, sorry, let's just do this real quick. Sorry. So if we add a student, that means now we have 4 that are passing and 5 total students, which is 0.8. 0.8. And then over here, we already have 2 students that are passing, but now we have 3 students that are passing. That's 1. So what we'll want to do is we want to keep track. We will monitor the let me see, the class that would achieve a better gain or profit. Well, how do we determine that? Well, we can do it here. So let's look at this here. Now let's do this here. And we'll call this up here. We'll call this gain or profit. So let's see this. So what did we gain? So we started with 0.5 and now we're at 0.667. So we gained, what did we gain? 0.117, 0.117, is that right? 0.167, how about that? Let's see, I think that's right. Okay, yes, that's correct. And here we gained 0.05, and the last one we didn't gain anything. So what we'll want to do is we'll monitor the gain in profit for every class. And so what we'll do to use that, what we'll use to do that, we will use a heap, or maybe to be more explicit, we will use a maximum heap. Okay, we'll do that. Now, suppose though, instead of k equals 1, we have 2. We have two students we can add. So what we'll do is we'll initially store in our heap, we'll store this. We'll store our gain, and then the current number of pass, so the number of passing, and number of total number of students. So we'll store 3 things in our heap: the gain or the profit, the number passing, and the number total. So in this case, we would remove this guy. So in our heap, we would take this off and remove it. But then we would put it back. So then we'd replace it in a way. Replace. So then what would we replace it with? Okay, so, well, the current one would be 2 out of 3. 2 out of 3 would be 0.667. But then, since we have 2 students, we want to check, well, if we add 1 more student to this class again, what do we get? Now we get 3 out of 4, which is 0.75. And well, what's the gain there? The gain would be 0.75. Let's figure that out. I don't know. 75, what is that? So it's 3. So 100, no, 90, so 50 plus 30, 80, 83. 0.083. 0. Point, sorry, 0.0083. 310, 14, 15. Yeah, that's right. I think that's right. So we would gain from 0.667 to 0.75, we would gain 0.083. So what we'll be doing is we'll always be using this approach here. First, we'll initialize our heap, max heap, to store what the original values, what the original gain is, and then we'll pop it off the best one, and then we'll store it. So actually, yeah, it's fine. So yeah, I'll write down the pseudocode in a moment. We'll pop it off, and then we'll put it back. We'll put it back. As long as we have more students to use, we'll keep doing this. So this is the 0th iteration. This will be the first iteration where we use this student. And then the second student is here. Second student. And then we'd always house many, depending on how many students we have, that's how many changes we'll make. That's how many changes we'll make. And then every time we pull a class from the max heap, we'll add the gain. We'll add the gain or profit to our result, and we'll just store that. Actually, no, we'll do it at the end. We'll do it at the end. That's probably better. Okay, let's kind of run through the pseudocode really quickly. Let's think. I don't even think that we need to. Yeah, let's just try to implement it. I think we're ready to implement it. So let's do something. So what we want to do is we'll make a heap. So we'll just do. Actually, let's do. What do we want to do? We want to do. Well, first let's make our heap. Let's do this. So Q equals. So we want our heap to store the gain, the number of passing, and the number of total. All right. So we want to loop through our class. So our class has 4 passing and total in class. And what we want to store is we want to store the gain. We don't know what that is yet so far. We want to store the current passing and the current total. So we need to calculate this. So what I'm going to do is create a quick lambda really quickly. So I'm going to say L equals lambda. And I'm going to pass in 2 values. So in fact, just P and T. So it makes it easier to understand. And then we'll say this returns. Now, remember the gain is calculated by subtracting the new value minus the old value. So the new value would be P plus 1 divided by T plus 1. Remember, that's what we did here. We added 2 to the old value and we added 1 to the old value for the passing and the students. And let's use parentheses here to make sure our order of operations are preserved. And so this would be the new value, which is 0.67. We want to subtract it from the old value to get this gain in profit. And this gain in profit is how the Q knows to pull out the best value. So we'll say minus P divided by T. That's simple. So this will be our like another function for just calculating the gain. So this is the new value minus the old value, which is basically the improvement. So just put that here, L of P comma T. Now remember though, in Python, that Python naturally comes with it's naturally a min heap. So we'll need to store the negatives to make it a max heap. And if you're still confused about that, let me know in the comment and I'll make a separate video for that. So let's go back here. So now we have our heap, but it's not in the heap format. So we need to heapify it. Heapify. Okay. What else? I think it's enough to get started. So they give us K extra students. So let's loop through that. So we don't really need to keep track of the students, but we need to do this K times for in range K. now I'm gonna go over two approaches here. I'm gonna go over the basic one first, and then I'll show a slight optimization later. So remember, we want to remove the best one. So let's use, what is it? Heap pop q, and what do we get? We get, so in the q we're storing the profit or the gain and pass and the total. So let's use that here. So we'll say maybe gain, pass, and total equal this. And what we'll want to do is we want to put back on the heap push q. So what do we want to put back? So, well, we actually don't need the gains. We don't need that to use it now. But we want to, so remember over here when we remove this, we want to put it back on the heap with new values, and then it'll be associated or compared with these other values that are already on the heap. So let's put it back. So how do we put it back? Well, we can use our lambda again. So our lambda again. So remember, we need three values. But remember, we're adding another student to this class. So we need to put p plus 1 here and t plus 1. Make sure we know we do that. And we need to use our lambda again to calculate the gain. So we use lambda of p plus 1, t plus 1. I hope this makes sense. And don't forget our negative in here, our negative in the front. So remember, these were the old values, but now we're saying, okay, we've already added a student to it. This means if we pop this value from the queue, this means this was the best class to add a student to. But now we want to say, okay, let's pretend we add another student. So that's what we're doing here. And I think that's fine there. And so at the end, what we'll have is, what will the queue look like? It'll have, and so in this case, it would look something like this. So it would be, so the current passing rate is 1 for these two, 1 and 0.75. So 1 and 0.75. And this guy would be, the last one would be, what is it? So 0.3, 0.75. So it doesn't matter the order here. The queue may not look like in this order. But remember what they ask us. Let's go over what they ask. They want to know, return the maximum possible average after assigning the extra students. Okay, so once we assign the extra students, now this will be the best, these values will be the best passing averages. So this already has the best passing averages, the best passing average pass ratios. So now we just need to do the final one for all the classes. So we say, let's loop through. So we'll say sum of q. So this will add all of this. And then we need to divide it by the length of q. And that will be the sum, what do they say? The average pass ratio after assigning extra students for all of the classes. Yes, the average pass ratio is the sum of pass ratios of all the classes divided by the number of the classes. So that's what we're doing here. And now we just return it. I think that's okay. Let's test it locally. What happened here? Hold up. Return sum of q. Oh yes, I apologize. Remember, q is in this format. So what we want to do is we want to just add the passing ratios. So something like we need to do something like for, we don't need this. We need the passing ratio. We don't need that either. And we just say something like this here. P. I think that's better. My apologies. Let's see if this works. What happened here? Oh, I'm sorry. Oh yeah. Anybody see what I did wrong here? It's a silly mistake. So remember though, this is the max cube. So these no, that's right. What went wrong here? 2.667. That's the pass rate. No, I'm sorry. This P is the number of students that passes. So we want to do this here. Yeah. There we go. And let's just submit it. And I hope you know I purposely leave these mistakes in this video because I want to show you that everybody makes mistakes and we just need to figure out how to solve it or how to get through it. Now, okay, I showed you, I wanted to go over a couple optimizations before we go. Notice here we're doing this heap pop and heap push. What I'm going to do is I'm going to convert this into one operation. So, because remember, we do this k times. And remember, k can be, potentially could be, what is it, 10,000? 5, 3, no, sorry. $100,000. Is that right? Let's see. Yeah, it's 100,000. So 10 to the 5th, so that would be what? 10 to the 5th, so yeah, 10 with 5 zeros. So we could have this here. So it could be 100,000. So we'd be doing 100,000 times 2 operations. I'm going to do it in 1. So just to make it a little bit better. So I'm going to convert this into one operation. I'm going to change this into heap replace. And what I'll do here is, so remember the way the heap works is that the first value always has the maximum or the minimum, depending on how you make it, the max heap or the min heap. So in this case, since we made this a max heap, this will be what we're looking for. It's the top one. It's the minimum. That's still what we want. So this is fine. I just replaced it. So now this is just direct memory access. So we've removed a function call, and that's good. And then we use heap replace, and I think everything else is the same. Q, yes, everything else, we don't need to change anything. This is perfectly fine. That's one thing. Let's just run it just to make sure it works. Then I also have another optimization for us. And let me just take off these comments. They're not really needed anymore. And one more small thing. Suppose now, remember we do this heapify? So we basically order the classes into, so whatever we have, suppose it'll be like, I don't know, remember this stores the gains, right? This stores the gains mostly. So the gain could be what, 0.2, I don't know, 0.1 and then 0.001. So they're always telling us the best gain. This will always be the best gain up on the first position. Now, what if they told us though, the best gain, suppose it was like this. Suppose it was 0, and who cares what it is back here? Doesn't matter. But they're saying the best gain is 0. that means they're all zeros. What does that mean? If the best gain is 0, and it doesn't matter, but this 0 would mean if this is the best gain you can do, that means all of them are zeros. That means all the students are already passing in all of the classes. So I hope that makes sense. You should maybe think about it if it doesn't make sense yet. So I'm gonna do a little check here. If q of 0, that's the first one, and this is the gain, the first value. If this equals 0, then you can just return 1. Because that means all of the classes are passing. So remember before we had 3 classes? So that means the passing ratio, it's 100%. When you add them up and divide it by 3, it's going to be still 100%. So I wanted to add that there. And those are my 2 slight optimizations. Let's run it locally. Let's submit it. Okay, great. So what did we do here? So our first submission was, it's a little bit better, and these are just little pieces of information that I want to pass on to you, just so we can all become better developers. This is probably Leetcode specific, but it's fine. It makes us look better. But this is probably the best one here. I kind of like this one, where we condensed 2 function calls into 1 because we understand how the heaps work in Python. Okay, great. If you found this video in any way helpful or beneficial, please consider liking or subscribing. Have a wonderful day. Take care.